Hi and Assalamualaikum. Today my groupmates and I will present about gas chromatography or GC. My name is Khairin Arina Huri binti Roslan. My group member are Nur Arina binti Rostam, Nur Rashidah binti Muhammad Razali, Ni Asya Nabila binti Ismail Husaini, and Nurin Atika binti Amir Shahid. My part is going to present about introduction and conclusion of gas chromatography. Introduction. GC is a technique for separating components based on their volatilities. In GC, the components of a vaporized sample are separated as a result of being partitioned between a mobile gas phase and liquid or solid stationary phase in the column. Gas is called a carrier gas. Pressure from compressed gas cylinder containing carrier gas is sufficient to create the flow through the column. There are two types of GC. The first one is gas-liquid chromatography, GLC, which means mobile phase as a gas and stationary phase as a liquid. The other one is a gas-solid chromatography, GSC. The mobile phase is gas and the stationary phase is a solid. The objective of this experiment is to determine the commonly used components in GC, to study the retention time of each samples, and to study the factors that affect the separation in GC.
Assalamualaikum and hi, my name is Niasa Nabila binti Ismail Husaini. Now, we will look at the methodology for gas chromatography experiment. In this experiment, we will analysis of ethanol in various samples. We will use ethanol as the analyte and 4 different samples, which is whole blood, whiskey, beer, and wine. Beginning with the sample preparation, firstly, the shrink will rinse before filled with the 4 different samples, and the volume of the sample may be more than the required volume. The shrink hold vertically with needle up and push longer to the required volume at the eye level. The sample injection will involve taking a small amount of the liquid sample to be analyzed into a shrink, and then the injection need to be done quickly into the hot injection part of gas chromatograph as the sample is volatile. The sample injection and vaporization. The time of injection is taken as beginning of the retention time of the ethanol. Temperature of pot is then raised to be higher than boiling point of ethanol, so they will vaporize. The vaporized ethanol then mixed with the inert mobile phase to be carried to gas chromatography column where the separation will be occurred. Next, for separation of components, the components in the sample will separated based on their adsorption rate to the stationary phase according to their polarity. Components that absorb strongly will stay in the column for a longer period and have longer retention time. The inverse is true for components with lower adsorption rate. Next, for the analysis of result, after the analytes have been separated and exited the column, the detector will detect them and the individual components of each sample will appear as different peaks in the chart. This peak is due to the components reaching the detector at different rates due to the different times they are retained in the column. And then, we will get the result, the retention time of the 4 different samples.
Assalamualaikum warahmatullahi wabarakatuh. My name is Norina Midrusa and today I would like to present the analysis part of this experiment. So continue to the analysis summary in this table, which the first column is sample, contain whole blood, whiskey, beer and wine. Next to it is boiling point of the sample, which we have 100 degrees Celsius is the highest boiling point and the lowest is 78.32 degrees Celsius. And then is injection mode. Injection mode in GC has only 2, which are split mode and split disk mode. Split mode is when a small amount of sample with high concentration is prepared into the column and therefore produce sharp and narrow peaks. And the split disk mode is very versatile to the split mode. And then we have the type of detector here. The type of detector that you will use in all of the sample is flame ionization, or we call as FID. FID is actually how it operates is actually the ionization of samples or solid molecules in the flame, and while the compound detected and the FID is actually only organic molecules that can be ionized. Next type of column, there is only two types of column in GC, which are the first is packet column and next is capillary column. Packet column is usually 105 meter and capillary column is 10 until 100 meter. And next is column temperature, which are vary in different sample. This is because column temperature is depend on the volatile of the compound. And next is the retention time. Retention time, we can see the lowest retention time is for whole blood with 0.43 minutes, and while the whiskey has the highest retention time with 2.73 minutes. And next is mobile phase or carrier phase. In this there is only two we use, which are nitrogen and helium. Nitrogen is cheaper than helium, but compared to helium, nitrogen is not really efficient like helium, although helium is expensive. So here is the graph for the blood. The retention time of ethanol is 0.43 minutes, and next is the whiskey. The retention time of ethanol is 2.73 minutes. And next is wine. The retention time of ethanol is 1.25 minutes, and beer, the retention time of ethanol is 1.48 minutes. So next is the discussion. Well, actually there are several factors that affect the separation in gas chromatography for samples, and it also affect the retention time. And so here the first factor is the volatility of compound. Low boiling point volatile components will travel faster through the column than the high boiling point components. And next, the factor is polarity of compound. Polar compounds will move more slowly, especially if the column is polar. So here there is the polarity of the compounds, which water is has the highest polarity and the lowest polarity is the aliphatic hydrocarbons. Next to it is column temperature. Although minimum temperature gives good resolution, but raising the column temperature speeds up all the components and all the compounds in a mixture, and therefore it can affect the retention time and the elution time. Next is flow rate of the gas. Speeding up the carrier gas flow increase the speed with which all compounds move the column. Helium has a shorter time run compared to nitrogen, but nitrogen is cheaper, like I already said in before. And next, the last is the one that the separation in gas chromatography is the length of the column. The longer the column, the longer the elution time. So packet column is 1 until 5 meter in length, and the carrier gas flow between 10 until 40 milliliter per minute, while capillary column is 10 until 100 meter in length. So here there is ethanol molecular formula, and which is boiling point for the ethanol.
To conclude, as we know that FID was used as detector, there are many advantages and disadvantages of this detector. For advantages, the FID is rugged, sensitive until 10 power of negative 13 G per S and wide dynamic range until 10 power of 7. It also signal depends on number of carbon atoms in organic analyte. The disadvantages is weakly sensitive to carbonic alcohol, and amine groups. It also not sensitive to non-combustible analytes such as H2O, CO2, SO2, and NOx, and this detector is destructive method.
Here is the references. Thank you so much for listening.